Had a lot of requests to do some related rates problems, and I think they're really nice problems on the AP exam. And they started to come up a lot more on the free response the last couple of years. So a lot of the good examples I have, though, are multiple choice, but similar concepts to what you see on free response. So we got a ladder falling down a wall here. And by the way, keep in mind the length of the ladder does not change. And if something is constant and unchanging, a lot of times I will kind of mark that in my diagram just to remind me, hey, this never changes, because related rates problems are all about what changes and what doesn't change. So anyway, ladder sliding down the wall. So you can see it's moving, base is moving to the left, the top is moving down. So you have different lengths here, and they give you those kinds of things. And so you have to come up with an equation to link these things. And so we're talking about lengths of sides of a right triangle. I'm going to use the Pythagorean theorem here. I'm going to call that side x, I'm going to call that side y, and I'm going to call this other side here z. And so we know that x squared plus y squared is equal to z squared. Okay, so remember the concept here is that you basically list out the rates that you have, and you take the derivative of your equation with respect to t, and you basically substitute everything and you get your answer. Okay, so this is the y side. The rate of change of that y side would be dy dt. The x side, the rate of change of that would be dx dt. Okay, and then of course the length of the other side, rate of change of the ladder would be dz dt. And so anyway, it says it's sliding down the wall at a rate of 3 feet per minute. So that's telling me that dy dt is going to be 3, but it's going down the wall. You do have to watch positive and negative signs here. So that's going to be negative 3. Anyway, we want the rate of change of the distance between the bottom of the ladder and the wall. Okay, they're asking us to find how far that x side is changing, and that's dx dt that we're looking for. So let's go ahead and take the derivative here. The derivative here is going to be 2x times the derivative of x with respect to t, which is dx dt, plus 2y times the derivative of y with respect to t. Oh, and the last thing here, notice they never mention the rate of change of side z. That's because the length of the ladder never changes. So be on the lookout for a case where you have something constant. If something changes, it varies. You need to keep that as a variable in the equation when you take the derivative. If it's constant, you can replace it. So the ladder length is always 25. I don't need a z variable in this problem, okay? And as a result, the derivative of a constant is just 0, okay? And at this point, we should be able to substitute everything in here and get an answer. The ladder is 25 feet long. It says the top of the ladder is 7 feet from the ground. So that means the base is 24. It's a little 7, 24, 25 problem here. Okay, so x is going to be 24 and y is going to be 7. And we are looking for, we know that dy dt is negative 3, and we can fill that in. And unfortunately, this is getting a little bit messy here, but we're going to have 48 dx dt. Let me get my picture out of the way here. 48 dx dt plus, let's see, 7 times 2 is 14 times negative 3. That's going to be, let's see, 14 times negative 3 is at negative 42. That's minus 42 is going to be equal to 0 when you substitute everything in there. And so anyway, if you saw that equation, you get 42 over 48, which is going to be positive 7/8. And that is going to be choice D as our final answer there. So little sloppy on the work end there, but that's the basic idea about how these things end up working.